Hi there, I'm Jules from WILDCOAST. In this video, I'll be walking you through our Desiccation Lab created for grades 1 through 5. Before I begin, there's some important information that you should know before starting the experiment. WILDCOAST works with the Ocean Protection Council, the California Department of Fish and Wildlife, and many others to manage California's network of marine protected areas in order to protect and restore the ocean's habitats and also increase the health, productivity, and resilience of the ocean's ecosystems. In California alone, there are 124 marine protected areas, or MPAs, that encompass 16% of our ocean's waters. MPAs can be thought of as underwater parks, similar to national, state, and regional parks on land. MPAs protect a wide range of ecosystems, including kelp forests, sandy shores, and the rocky intertidal. This lab will focus on the unique and fun rocky intertidal. The species that live in the intertidal zone are subject to the rigors of both the land and the sea, going from completely submerged to only occasionally wet within just a few feet of space. These organisms must endure extreme fluctuations in moisture level, temperature, salinity, and sunlight. MPAs limit or prohibit which intertidal organisms may be taken by humans, reducing the stress and safeguarding resources on species within these dynamic environments. This lab will explore the idea of desiccation, or drying out due to exposure to the sun. Many tidal animals, such as sea anemones, have learned to protect themselves from drying out by covering themselves with shells or algae during periods in which they will be out of the water. You can imagine that the shells and algae are kind of like sunblock for these tidal animals. MPAs protect these types of animals by limiting or prohibiting take of resources such as shells and algae, leaving more covering material within the area. In this lab, we will create two tide pool models, one within an MPA and one outside of an MPA. So you want to start with two separate containers. In each container, you are going to put dry dirt or sand. I use dry sand in my containers. Now you're going to take two sponges, which will represent sea anemones. You want to get each sponge wet, wring it out, and place one in each container. This will simulate the anemones having been soaked in the tide pool all day, but now being exposed to direct sunlight and dry conditions. In order to protect the sea anemones, we will be using shells to represent their sunblock. You will want two separate boxes of materials to cover up the sponges. The box of materials for the MPA should be full and provide various items to use as cover, while the box of materials for the non-MPA should be relatively empty, representing a lack of shells due to people collecting them in the unprotected area. Have students choose items out of each respective bin to protect their sponges. Most of the sponges in their non-MPA model will be uncovered. Once the students believe that they have sufficiently covered each sponge, bring them outside if possible, or place them under a sunny window. A Desiccation Lab datasheet will be provided for your students, or you can make your own. On these sheets, have your students make a hypothesis about what they think will occur in both the MPA model and the unprotected model. Then, have students make predictions about how long they think it will take each sponge to dry out by guessing whether each sponge will be wet, very damp, damp, slightly damp, or dry for each time interval. Fill this out under our guess column. Check the sponges every 15 minutes or whatever time interval works best for your class, and record the data under the Real Data column. Continue until the sponges are dry or until you reach the end of your allotted time during class. Once the experiment is complete, discuss the students' predictions compared to the real data. This Desiccation Lab is meant to relay the importance of marine protected areas to students. As the results suggest, the sponges in the unprotected model dried out much quicker than the sponges in the MPA model. This simulates a real issue where people are taking resources like shells out of tide pools, thus leaving organisms like sea anemones unprotected from the sun. I hope this lab engages the students in conversation about MPAs and also raises awareness about these issues. If you need any further information, you can visit our website at wildcoast.org and click our Resources tab. But most importantly, I hope you have fun.